Good morning everyone. In this particular video lecture, we will discuss the concept of capacitance. Now my dear friends, as you can see here, it is the ability of an element to store electric charge within it. Now from this line, it is clear that if we talk regarding the capacitance, then capacitance is basically a property of any substance due to which it stores electric charge within it. And the second one is that is a capacitor stores electric charge in the form of electric field being established by the two polarities of charges on the two electrode of a capacitor. Now my dear friends, as you can see in the below figure that there are two electrodes and both these electrodes are connected to a supply source. Now my dear friends, according to the polarity of the battery, positive and negative charges will accumulate on these two electrode. As you can see here, this electrode is positively charged and this one is basically negatively charged. And now in this case, my dear friends, these both electrodes will be have as a capacitor and they will store electric charge within it. Now my dear friends, the third one, that is capacitance, is a measure of charge per unit voltage that can be stored in an element. Now my dear friends, we can also say that capacitance, that is C is equal to Q by V, means we can say that charge per unit voltage is also known as capacitance, or we can say that charge per unit voltage which can be stored in any substance is known as capacitance. And my dear friends, it is basically its unit is farad, and we can say capacitance is measured in farad. Now my dear friends, if we talk, then basically capacitance is denoted by capital letter C, and if we talk regarding its symbol, then as you can see here, we can denote capacitance by using any one symbol out of these two. These both are basically same. The first one is basically, you can say here, somehow bent at both the ends, and the second one is basically this one. And as you can see here, in the second one, in the second case, both these two lines are of equal length and no one is bent at its end. Now my dear friends, these basically are the symbol of capacitor, and it is basically denoted by the capital letter C. Now my dear friends, as you can see here, as we know, Q, that is charge, is directly proportional to voltage. Now from here, if we remove the sign of proportionality, then a constant will come into play, and that will be equal to Q is equal to CV. And now my dear friends, this is basically the capacitance, or we can say the capacitor. And if we calculate the value of C from here, then it will be C is equal to Q by V. Means charge per unit voltage stored in an element is known as basically capacitance. Now my dear friends, the next one is that is, we will now calculate the value of current in a capacitor. Now my dear friends, as we know, the value of current, that is I, is equal to differentiation of charge with respect to time. As you can see here, I is equal to dq by dt, and also we know that q is equal to CV. Now my dear friends, as we put the value of Q here and differentiate, then the value will be I is equal to C into dV by dt. This is basically the formula for calculating the amount or the value of current across a capacitor. And we can see here the value of current, that is I is equal to C into dV by dt. Now my dear friends, this is basically the value of current we can see across a capacitor. If we want to calculate the value of voltage, then as we know, my dear friends, as we know, if we calculate the value of dV by dt from here, then it will basically comes dV by dt is equal to 1 by C into I dt. If we calculate the value of dV by dt from here, then it will be 1 by C into I into di by dt. Now my dear friends, if we differentiate the value of dV from initial voltage V0 to final voltage Vt, then the equation becomes integration from integration from V naught, which is initial voltage of the capacitor, and Vt is the final voltage of the capacitor. dV is equal to 1 by C, and integration from 0 to 2 means initial time is basically 0 and final time is basically t, idt. And if we calculate its value, then the value will comes out to be Vt minus V0 is equal to 1 by C integration from 0 to 2 idt. And if we calculate the value of Vt, that is voltage across the capacitance, then it will basically comes 1 by C integration from 0 to 2 idt plus V0. Now my dear friends, here one point to be noted is that the V0 is the initial voltage of the capacitor. If the voltage is initially discharged or completely discharged, then the value of V0, that is initial voltage, becomes 0. And my dear friends, in the equation, if it is given that the capacitor is initially charged, then some amount of the value of voltage will be given, say let us example 5. Now my dear friend, this is basically the initial voltage of a capacitor. As you can see here, where V0 is basically the initial voltage of capacitor, Vt is basically the final voltage of capacitor. And now my dear friends, as we know, I is equal to C into dV by dt, and if we calculate for dc, then as we know the value of dV by dt for dc is equal to 0, then we can the value of current, that is I, will become 0. Hence if the value of current is 0, then we can say in case of DC current when passed through a capacitor, then the value of current will be 0, means it behaves as an open circuit. Now my dear friends, this point is very much important from the objective point of view, so it should be kept in your mind that if for a DC the capacitor behaves as an open circuit. Now my dear friends, if we want to calculate the amount of power absorbed by a capacitor, then as we know the value of power is equal to P is equal to V into I, and here if we put the value of I, that is I is equal to C into dV by dt, C into dV by dt, then the whole equation becomes P is equal to VC into dV by dt watt. Now my dear friends, the next we will calculate the value of energy stored by the we will calculate the value of energy stored by the capacitor. Now my dear friends, as we know the energy stored is equals to the integration from 0 to 2 p dt, means integration of power from 0 to 2 is equals to the amount of energy. Now my dear friends, as we know the value of power here we calculated is Vc into dV by dt, and we will put the value here, and the value of amount of energy will comes down to be 1 by half CV squared joule. Now my dear friends, this one is basically the main formula for the calculation of energy stored in a capacitor. Now my dear friends, if we put the value of C is equal to Q by V here, then the equation becomes half QB, and if we put the value of V is equal to Q by C here, then the whole equation for the power will becomes half Q square by C joule. Now my dear friends, these all three formula are same, and we can calculate the amount of energy stored in a capacitor by using all these three formula according to the data given in the question. Now my dear friends, we will now move to the next topic, that is the connection of capacitance. Now my dear friends, as we know there are basically the two connections. The first one is series connection and the second one is parallel connection. Now my dear friends, the first one is series connection. As you can see here, current is same across all the capacitor, means in series connection the value of current will be same across all the capacitor, and the value of voltage will be different across all the capacitor. Now my dear friends, as you can see here, there are basically two capacitors. The first one is C1, the second one is C2, and the voltage across capacitor C1 is V1, and the voltage across capacitor C2 is V2. And now we want to calculate the basically the equivalent capacitance value. Now my dear friends, as we know the amount of voltage across a capacitor is equal to 1 by C integration IDT, and now my dear friends, if we want to calculate the total voltage, then the total voltage is equal to V1 plus V2, that is voltage drop across capacitor C1 and voltage drop across capacitor C2, as you can see here. And my dear friends, if we this is basically the equivalent voltage, and if we put the value of equivalent voltage, then 1 by C equivalent integration of I dt, and this one is basically the voltage drop across capacitor C1, and this one is basically the voltage drop across capacitor C2. Now my dear friends, if we as you can see here, this one will become cut out, and because these terms are common in all these terms is common, and now my dear friends, as you can see here, 1 by C equivalent is equal to 1 by C1 plus 1 by C2, and if we want to calculate the C equivalent, then it will become C1 C2 by C1 plus C2. This one is basically the we can say the equivalent capacitance value when two capacitor is connected in series. Now my dear friends, we will now calculate the voltage according to the voltage division rule. We will now calculate the amount of voltage across each capacitor. Now my dear friends, as we know, the V1 is equal to 1 by C1 into integration I dt, and we also know that from equivalent capacitance and equivalent voltage, if you calculate the value of integration from I dt, then it will basically comes V into C equivalent. Now if we put here the value V into C equivalent, then it will basically comes after calculation. V1 is equal to, means voltage across capacitor C1 will be equal to the final voltage into C2 by C1 plus C2. And in the same way, my dear friends, if you want to calculate the voltage across capacitor C2, then it will be V2 will be equal to the equivalent voltage V into C1 by C1 plus C2. Now my dear friends, we will move to the next topic, that is the parallel combination of capacitance. Now my dear friends, as we know, voltage is same across all the capacitor in case of parallel connection, and the value of current is different across all the capacitor in case of parallel connection. Now my dear friends, using this concept, we will move to the next topic. As you can see here, there are basically two capacitors. The first one is C1 and the second one is C2. Both these two are connected in parallel with each other, and the amount of the value of current flowing in capacitor C1 is denoted by I1, and the value of current flowing in capacitor C2 is I2. Now my dear friends, as you can see here, we know that current across capacitor, is equal to I is equal to C into dV by dt. Now we will use this concept here, and if you want to calculate the equivalent current, then that will be equal to I1 plus I2. Now my dear friends, using this concept, we will move further, and as you can see here, I is equal to I1 plus I2, and then I, that is equivalent current, is equal to C equivalent into dV by dt, and this one is basically the current across capacitor C1, and this one is basically the current across capacitor C2. Now my dear friends, if we calculate, then C equivalent will be equal to C1 plus C2. Now my dear friends, here we have to keep in mind that in case of parallel connection, the equivalent amount of, or the equivalent value of capacitance is equal to the C1 plus C2, and in case of and in case of series connection, it is equal to C1 into C2 by C1 plus C2. Now my dear friends, here we will basically calculate the value of current across flowing in each capacitor. Now as you can see here, as we know, I1 is equal to, means current across capacitor, C1 is equal to C1 into dV by dt, and my dear friends, from the equivalent current we will calculate the value of dV by dt, and the value of dV by dt will be I by C equivalent. And if we put here the value, then the value of current across capacitor C1 will be equal to I into C1 by C1 plus C2, and in the same case, in the same way, if we calculate the current flowing through capacitor C2, then it will be equal to the I into C2 by C1 plus C2. Now my dear friends, here this one is the most important point to keep in mind, that the calculation of resistance and calculation of inductance is same. Now my dear friends, these 2 points is very much important from the examination point of view. that the calculation of resistance and calculation of inductance both are same, and the calculation of conductance, that is G, and the calculation of capacitance are same. Now my dear friends, this is basically about the concept of capacitance. Now in the next video we will discuss some numerical, or we can say objective questions based on these concepts. Now my dear friends, that's all. Thank you.